Good news. We're going into polynomial multiplication and division, and we're going to start warming up into some pretty serious algebra soon. So let's begin with warm up. X times x. This is really good. So in this first term, x, both x's are raised to the exponent. Now, let's recall what the definition of an exponent is. It's simply implying repeated multiplication. So x times x is really x to the power of 1 times x to the power of 1. And by definition, how do we say x times x? Well, we say that it's x to the power of 2, or x squared. So we may wish to recall the product of powers, in which, if you have the same base, you simply add the exponents. Let's move on to the next one. I'm going to write repeated multiplication here. So I have x. I'm going to write down what it means, x, times. Well, now this is 3 times x times x. That's what 3x squared is. So what can I do? You know what? I'm going to do one better. Instead of writing x in purple, I'm going to write it in green. So I'm just going to reorganize my multiplication. I'm going to call this 3 times x times x times x. So when I multiply them, I'm going to say this is 3. Now x times x times x is repeated multiplication, so I can rewrite that as 3x cubed. Now notice how the variables sort of go together and the coefficients don't have anything to do with the variables, almost like two different questions. So now I'm kind of hoping what we're able to do with this one is I'm going to write it as repeated multiplication in this really weird expanded form. By the way, 4x squared is 4 times x times x. That's what 4x squared is. Now what I'm going to do is I'm going to multiply it by 3x. So I have 4x times x times 3 times x, and with multiplication we get to mix up the order. So I'm just going to group the coefficients beside each other. I'm going to regroup all of the variables beside each other. So 4 times 3 in the blue is 12. X times x times x is x to the power of 3. So let me have another crack at this. I think that I'm thinking of this a little bit differently now. My coefficients and my variables are multiplied to each other independently. That is, when I go 4 times x squared times 3 times x, I reorganize it so it appears as 4 times 3 times x squared times x. And the answer will be 12. Now x squared times x, right? And if you want, we could write it as x to the power of 1. We multiply it, and we simply add the exponents. All right, I feel good. Now, here we are. Let's go on to some other notions. Now, x divided by x. We have this weird thing in math that we feel this compulsion just saying that, hey, the denominator can't be equal to 0. So I'm just going to put x can't be 0 because the denominator, we can't divide by 0. But x divided by x, what happens is I have a factor of x in the top and the factor of x in the bottom. Uh-oh. What happened? Well, really, this is just 1. Any quantity divided by itself is 1. And maybe I'll just put 1x divided by 1x. And what we'll see is we have a factor of x in both the top and bottom. So they would cancel each other out. And what I'm left with is 1 over 1 or 1. So what we see is that for every factor in the bottom, we can cross out 1 in the top. So let's go 4x squared divided by x. So I'm going to use my expanded multiplication. That's 4 times x divided by x. Now, I'm going to think of the coefficients independent. Now, 4 divided by what? Well, there's really secretly a 1 in the bottom. 4 divided by 1 is 4. Now I have x times x divided by an x, a common factor of x, so they cancel out, which just leaves me 4x. Now, here is a nice helpful hint as well. If you recall, all the way back to the exponents unit, if we divide some base to the power of m divided by some base to the power of n, what we do is we subtract the exponents. Well, same thing goes on here. This is right here, this is x to the power of 2 divided by x to the power of 1. So we can just say this would be equivalent of saying 4x to the power of 2 minus 1, or 4x to the power of 1. All right. I think I'm getting it again. The coefficients act independent of the variables. So it's almost like two questions. We deal with the coefficients numbers, and then we deal with the variables. So now if I have 16x squared all over 4x, well, now I'm going to view this as 16. I'm going to view it like this and think of it like this. 16 divided by 4. So I'm going to put the coefficients together, and then I'm going to put the variables together. 16 divided by 4 is 4. X squared divided by x just leaves me with x.